Welcome everyone. This is the Let's Build session on Vonk FHIR Facade. It's a 40-minute session, which means we can't just do the exercise because I will need to explain how it works. But afterwards I will be available at the Meet and Code. There are two tables marked as building servers, and that's where I'll be. So you can join me there to actually do this, or do it back home, of course, if you like, or have other sessions. Well, we can be quick about this, but there's a quick. But I need to do a check. Who here prefers an IDE over PowerPoint? Yeah, so you're mostly developers. And who has worked with Vonk before or played with it? A couple of them. All right. Then I will tell what Vonk is. That's me. You can just look it up in the slides later. And this is what we're going to do. Prerequisites, you already saw them for a couple of minutes, so that's not too bad. And then what is Vonk actually? Vonk itself is a FHIR server, and it can be deployed in multiple forms. You can do that CDR as a whole. You can use it as a platform, a backend for your apps. It has multiple storage implementations, multiple databases. Of course, you can use it as a facade. That's why we're here. It also has a plugin framework. I had a session on that Monday. If you're interested, look at the recording or ask me. It's on .NET Core cross-platform, means it runs everywhere, including Docker, Kubernetes, any cloud environment. We built it in .NET. We have built the reference implementation for FHIR Server in .NET from the scratch, from the beginning of the standard. On to Facade. What is a facade? A FHIR facade. A FHIR server is an implementation of the FHIR RESTful API. Who here is not familiar with the FHIR RESTful API? It's basically the HTTP and the search HTML pages of the spec. But a facade is that you implement it as an interface on top of an existing backend system. So it could be database, could be maybe existing services, but something that's already there that you want to expose as FHIR, instead of just putting a whole FHIR server next to it. So you put a facade on it, and these are the facades, as you may know, and if you don't, come to Amsterdam in November, of course. To explain how what it looks like, I have 4 diagrams to see how you can arrange Vonk. If you just open the box virtually, this is what you get. And Vonk is, here's the RESTful API, and anything you send to it will go through a whole pipeline of different components that can handle all of that. And there's an implementation of a repository. By default, it's SQLite, so you can just experiment without installing a database. But of course, we have others that will come. And there is a second branch to this where we have the administration resources, or the conformance resources like search parameters, structure definitions, and a couple of others that influence the way Vonk behaves. So that's when you just open the box. Then you can change the database. That's configuration, because we have implementations of all of these. But the takeaway of this is this light blue interface that stays the same. It's the implementation that changes. Also, the rest here and here all stays the same. We have it on SQL Server, on MongoDB. There's even an implementation on Cosmos DB, but it's not fully complete yet. And then you can do a plugin. That was my previous session. I'll just show it quickly. You can say, I want some custom things to happen in this pipeline. I have some operation, a custom operation maybe, the $document is what we implemented. You plug it in into the pipeline, and it will be recognized and handled then by the server. You can write it yourself and just put it in the server, add some settings if you need to. So you inherit all that's already there for configuration, logging, the whole administration pipeline. You can also put one wherever you like it in the pipeline. But for today, the focus is on Facade. That's less about putting things in the pipeline, but implementing your own implementation of that. You could also do that against backend services. For the sake of the example, we will do this. Most people will be familiar with that. It's easier to set up a quick database to work with. But it could be anything. Okay. Now, the fun is that building a Facade is like building a plugin, except that you don't build the components for in the pipeline, but all of the rest is pretty much the same. So who here was at the plugin talk by any chance? Well, not too much overlap, but you'll recognize things. These slides, for example. But this plugin contains implementations of the two interfaces that define the storage of Vonk. It's the search repository and the change repository. Actually, fully it's iResource change repository. But and what's the advantage of this? You can utilize the full Vonk server setup as the vanilla Vonk, but then with your own storage. So you have the administration API. You can pull components in and out. You can combine it with plugins. You could have, if you implement the correct search parameters, you could then rely on subscriptions or smart authentication, etc. So it allows you to focus just on your logic. What does your data look like and who's allowed to change it? Slightly more, if you open up this architecture a little more, you still see that pipeline here and also here. So this is the middleware that's being used in ASP.NET Core applications, because that's what Vonk is built on. And this is the services that actually do the work. This is interesting if you're building components and plugins. The interesting thing here is the green part. So this is the interface. They all talk to the interface. That's the takeaway. So you implement the interface, and you're done. You don't need to worry about all of this above the line. But what you do need to worry about is mapping data back and forth and queries. Because that's the thing we don't know in the Vonk implementation, what your database looks like and what your data looks like. We know what resources look like. We know what the FHIR search looks like. And we'll get there on how we break that down to make it easy to make that mapping. So it's a bit of Vonk, and you add a bit of your own. You already have that database. You get Vonk until that green line, and then this part in the middle is what we're going to build. Why do we do this with programming and not with configuration? It's more flexible. You can do anything with programming, accessing different databases, whatever you like. If you do this with configuration, you'll have a lot of configuration. If we see common patterns emerge, we may move that over to some form of configuration, maybe in combination with the mapping language, but that would be future use. We'd rather do something 2 or 3 times and then see the pattern than impose a pattern on you that will not work. Here's the link to the GitHub that I already said, so you can just clone the stuff. And then we're going to dive into the project. So with the Facade starter, you start with a vanilla Vonk. And then we'll go from there. We're going to do all these items one by one. So where do you get that Vonk? Right here. You just go to Simplifier, download an evaluation copy, including a license. The license is fully functional for a month. If that's too short, apply for another one. There's also a Docker image. To experiment with plugins, it's easier to have the binaries because you can stick your own DLLs in. That's also possible with Docker, but it's more work. So next up, we need a project to build our Facade. And this is an ASP.NET Core server, so we built a library project in .NET Core to make this happen. Library project looks like this. Every library project basically looks like this, and we need a couple of things. We're gonna talk to a relational database, and Entity Framework Core works for that, so that's why we use that. And we need a couple of things from Vonk. These packages are all on NuGet. Then we use, for this example, we use an example database, and there's a script. In the repository, you can see this if you are in the repository. This is a let build, you're not going to just see PowerPoint. Vonk Facade starter, here it is. There's a scripts directory, and it has the create database. That will create the database for you. And it will create these two tables. They're easily recognizable, but they're not FHIR resources. That is for sure. We shortened the project to VZ for vital signs. So you can set that up yourself. The script was built for SQL Server, but it should be easy enough to work with for SQLite or any other relational database. Now, next, if we have a database and we have a project, we need to be able to access that database to get data in and out. In Entity Framework Core, that's done through a DB context. And you can reverse engineer that. You can also write it by hand. Given these two small tables, that it is easily done, but it looks basically like this. VG context is a DB context, and it has database sets for that blood pressure and that patient. The equivalent of the tables in the database. Anyone who has previous exposure to .NET programming with Entity Framework will recognize this. As I said, if you need some settings, and you do need some settings because you need a connection string to the database, you can just add that to the Vonk settings and add your own class to recognize them. That, in this case, that's the DB options class that only has a connection string element, so it's not on here. But we can see it for real in the code, because I also like Visual Studio better. So here's the DB options class. Well, that's pretty straightforward. And ASP.NET Core makes it easy to map these things together. So you can just inject it and get it. So we have a couple of basics in place. We have a database, we have a project, we have something to talk to the database. And now we're going to implement the search repository. This is by far the hardest part of the whole project. Searching is the hardest part of a FHIR server in general. So we're going to make it easier for you. We can take away all the complexity. What we're going to do? If you see, the search repository looks like this, and we're going to provide a bit of background, especially on the query context, and on the main method that is search.
Is that purposely a base class instead of a search repository?
Yes, I will get to that in the next slide. Maybe you've seen here the dependency on Vonk Facade relational. That is a project that we created to make it easier to access a relational database in a Facade. You don't have to use it, then you just implement the iSearch repository. So the iSearch repository search does get the argument collection and the search options. It doesn't have that resource type, but I'll get to that. The important thing here is what we're going to talk about is this arguments. If you do a FHIR search, like /patient, question mark, name is Fred, and identifier is ABC, those are arguments. In Vonk, we treat all of that as arguments. So the /patient is also an argument. If you have headers, they're also arguments. And we tell you where they come from. So you get the raw arguments, and you are free to do with them whatever you like, if you feel like that. But in general, that's a lot of work that we can do for you, so that is better. So you relay them to Vonk. Now, this is already in Vonk, and this is going to be a slightly complex diagram, but once you get the hang of the code, it's easy to replicate it for different classes and different searches. This is already in Vonk, you don't need to build it. The search service is one of those components in the pipeline. So that orange circle we have. Oh, that's a lot back. One of those circles is the search service. Luckily, this is fast. And it will say, search me with these arguments and a couple of options. I will dive into that right now. Then on the other side in Vonk, we have a query builder and a query context. And you can ask the query context to analyze these arguments. Tear them apart, see whether they are valid. Do they belong to this resource type? Does Vonk know them? Because that's the administration API. If we don't have the search parameter definition, we cannot evaluate it. And then it will tear them all apart, and for each parameter, it will call filter on this name, parameter name, and this value. And we have a couple of values there. I will explain that in detail. And the crux of this is that you have to implement this part yourself. Looks like a lot of classes, but it's not too bad. Search repository, we were already working on that. We were implementing the search method on that. There's a DB context, we already have that. So there's a resource mapper that we're going to dive into that later. It's going to be able to map to and from FHIR resources. And then there's a query factory, and that's the interesting part here. Because what is the problem here? Right now, we are using Entity Framework Core to access a relational database. You say, we do that with Link. Anyone unfamiliar with Link? Because we're going to have a bit of Link on the screen. So that's easy. But the next facade will be accessing SOAP service. That's slightly harder with Link. Or maybe another RESTful API. So we cannot define what your queries will look like. So we let you define that. And that's what happens in the query factory. So Vonk finds out what to query for. For instance, if you ask for ID, or actually underscore ID, that's a token search parameter. It's essentially code with an implicit system. If you do the value for an observation, that's a quantity. So that's a different type of search parameter with different elements in it. Or if you have a name, that's a string search parameter. All these types of search parameters are listed on the search page of the specification. And then for each of those parameters, it calls filter, and you get to control how you construct your query. So in this case, in the background, we will construct link statements. But maybe in another case, you want to construct URL arguments to access another web service. Well, when all of that is done, then you also get calls for and or, because if there are multiple arguments, you have to AND them together. And since you know what your query looks like, you have to AND them together. For link, that's simple. You just AND them together. For URL, you just put an ampersand between it and then combine them. And then when all is done, the query is returned to the search repository. That's also in your realm. See? So in the end, all these things return queries, and it will all add up to a single query. And when that's done, it's being returned here to the search repository, which is also built by you, and you know what that query looks like. So you also know how to execute it. You do that, you get back results, hopefully. and you map that to FHIR resources, and you use the resource mapper to do it. Yes?
Can you explain what the create query part, the very beginning, is doing one last time? So search arguments.
It actually, yeah, it tells the query, it just hands over all the raw arguments to that query context, which together with the query builder that's mostly internal or opaque to you, will tear all those arguments apart. The only thing you give it is that query factory to call to for each argument. Yeah, one last thing maybe about this diagram is some people may have expected an abstract syntax tree for the search that you then analyze. We decided not to do that because there's a couple of filter values here that you can respond to, and that's relatively simple. The problem with an AST is you have to know which combinations are actually being used, so you have to implement them, although the tree might allow for more structures. So we think this is slightly more confined to what we actually will call. So as I said, the query factory defines and constructs that query class, whatever that may end up being. In our case, it will be link statements. So the query class, as I said, it can be anything that holds information for that query. It can also be different per type of resource. So if you have, for instance, in this case, we have different tables that will require different queries. If you have a web service, it will maybe require different endpoints. You make a query factory for each type of query, and then the query factory gets to decide which arguments it accepts or not. So any argument that you get that you don't understand, you just ignore it. On the relational part, because we're doing this with a relational database, as I said, the Vonk Facade relational has a couple of helper classes to make it slightly easier to do this for relational databases. So that's these three classes that we will derive from. So this is the, what's it called? Derived classes. We begin with the interface, and there's the Vonk Facade relational search repository. And what it does up front is Vonk itself is capable of handling queries against multiple types of resources at once. I don't expect you to implement that. So the first filter we do here is say, is this only for a single resource type? Yeah, okay, then we'll pass that resource type to you so you know what to query on. If no, then we'll just ignore it. And then on this one that we're going to implement, what we're going to do is we check the resource type. Are we searching for a patient, for an observation, searching for something we have no idea about? We create the appropriate query factory, so we get the right queries out of it. We do that call to the query context to say, okay, create a query for me. Here's the factory to call for each argument, and now get those arguments out of the way and make it to something I understand. Then execute that query, map the data to resources, and assemble it in a single search result. We're going to see that. Maybe it's also...
Is it a formal template pattern, or it's just the logical steps that you follow?
It's the logical steps that you follow. In code, this looks like this. Here's the search method that we implement. I check, is this a patient? Then I'm going to search for patient. Is this an observation? Then I search for observation. Splitting this across different methods is mainly for readability, maintainability. You don't have to do that. If you can use the same search for different kinds of resource types, by all means. If not, we're going to throw a not implemented exception, and that will just end up somewhere in the operation outcome of Vonk. We'll say, can't do this. And then on search patient, we say in the create query, that's what with my factory, a patient query factory, I'm going to construct or craft a query on the patient table. In this case, to make the execute later on work, to make joins work, we have to pass the database context in. That's the way this query factory is being constructed. And we give it the arguments and a couple of options on the search. So, also we this step was actually not in the list. We do an execute count to see how many resources actually match to fill up the bundled total. If we don't return all the resources, we can communicate how many resources there are matching. Then, if we had any, we execute the query, bring it into a list, make sure you don't have too many in this query, so top it off at 10 or 20. By default, Vonk will add a top of 10, because otherwise your list will take a lot of time. And then you map it. So here's the mapping. And you assemble it in our search results. So that's what the code looks like. And then we're going to dive into a little more detail of each of the steps. So the query factory, that's the next thing we're going to visit. It has a method filter, and it has a parameter name and a value. The value is of iFilter value, and there are a couple of types of that. So you can filter on resource types, usually just only one, but it can be multiple. String value, so that's for string search parameters. Datetime value for datetime search parameters. It comes with, for instance, the lower band and the upper band of the range. A token value, which comes with the system and a code. The URI value, which is basically the single URI. Quantity is more difficult because it has the amount, it has the unit, a system where the unit came from. And then we have reference, basic reference, and to and from. The last one is also interesting, it's a raw value. It means Vonk has no idea what this search argument is about. There's no definition for it, so I don't know what it is. But you still get the chance to answer to it, because you may accidentally know what it is and allow your clients to search on it. So you don't need a formal definition of it. You just say, oh, I know what it is. It maps to this field, done. A bit more on reference filters. They effectively create a join, because you use them. Is that on the slide? No, not here. You use them for chaining. So if you ask for observation.patient.name is Fred, you chain the search. Because you hop from one resource type to another. And if you do that, then observation.patient is a query on observation, but patient.name is suddenly a query on patient. So what you do there is you create that subquery on patient and just hand it over back to the query context. Say, do the rest for me. This will be a patient query, and then I will join it with the observation. And if you can't join, you'll have to evaluate the search for patient first and then use the IDs to search on observation. For example, in the Mongo implementation, that is, we have to do that because it has no joins. An example of reference to. So this is what I said. It's observation subject. In this case, I didn't take the patient search parameter, but the subject search parameter. It can be a patient or a group. So I have to specify that it's about a patient this time, because the group has no name as far as I know. And then what you do is here, let's say, okay, I know subject, so I'm going to do, oh, that's not going to work. That only works in real code. I know subject, and it has to be target patient because I don't know anything about groups. And if that's true, then create a query on that value. This is a simple extension method to create that subquery with everything that's beyond the dot. So in this case, dot name is John. And then I execute that and select the ID, get the IDs, and say it should contain those IDs. By the way, because this is all linked, the execute sounds like an execute, but it returns an iQueryable. So in the end, it will all be executed together in a single statement. All right. There's also a reference from for reverse chaining. And there is simple reference, and that's if I say observation.subject is patient/123. I know the direct reference, so you can use that to search on. And you're effectively not chaining. Now, if there's an error, that's not too hard. If it's unknown to you, just ignore it. In FHIR Search, any arguments that are not known to the server or cannot be evaluated, they can be ignored, and you just return a set of results that fits to the rest of the parameters. It will be notified in the operation outcome in the return bundle that this was not supported. If there's something wrong, so you know the argument, you understand the argument, we say the value is wrong, for example, you can raise an argument exception, and also that error will show up in the operation outcome. If you think that an argument cannot be safely ignored, you can also, you have these raw arguments, you can still set it to must handle. And sometimes it's already set to must handle. In that case, Vonk will not return results. It will just return an operation outcome saying that this argument was not supported, but has to be supported. One example is the read operation where the ID must be understood. Quickly back to here. So we have a patient query factory. And we say we have add value filter for token value here, and it understands the ID parameter. ID was a token search parameter. In this case, I try to parse this into a long, and if that's not possible, I throw this argument exception, because I know in my database this has to be an integer, so if you ask for something else, something has gone wrong. This is what I meant by why you can focus on your own model and your own business rules, because if you decide to accept that and just return nothing, that's your choice. If all is well, we return a new predicate query, so something that returns a Boolean. ID has to match this patient ID. Another token value could be identifier, which is also a code plus system. So, oh, we know that as well. We map that to patient number value code. In this case, we should probably also check whether the system is correct, whether we know the system. But this is a basic example. We don't have all the checks in place. And we return that filter. And here's another one. Here's the reference from. As I said, it's for reverse chaining. So it's kind of the reversed way it works than the reference to that we saw on the slide. This is all online, so you can check back on it later. So now we get parts of a query, and they are being ANDed together. The AND and OR are already handled in that Vonk Facade relational for you. You don't have to bother with that. So then you need to map the results back to resources. Let's have a quick time check. I have until 11:05, I believe. All right, so we're going to map that. Well, we should at least show you something of it. Resource mapper, pretty solid name, I think. So here, map, I have, map patient. So I get something from my database, that's why it's VC patient. I have to return an iResource. iResource is an abstraction of resource across multiple versions of FHIR, across all the resource types that we use in Vonk. Yes?
So if I had my own existing API, needed to make an HTTP call, would that be somewhere within this context, or where would I actually do that? If I had my own API.
Yeah, you would not use the Vonk relational, Vonk Facade relational. You would implement your own iSearch repository, and then on the search you would still use, say, create query. You make that query factory, but that query factory will return a query class that essentially contains parts of your query string into your backend service, instead of what it's now returning, link statements that I can execute against the database. And how you AND and OR them together, that's up to you. By the way, OR is only, on search, it's only allowed for the same, for repeated values for the same argument. So it's not, you cannot have it on any level. Is that clear? All right. But the simple thing is here, you just create a new patient. This is from the FHIR.net API. It's the patient POCO. And you fill in the details from your database. You say return patient and then map it to create an iResource from it, because that's what Vonk needs. Then next, assemble the stuff in a search result. So that's basically a list of the results. And we also include how many we return, how many in total there were. You don't have to care about creating a FHIR bundle of this. Vonk will do that for you. You don't have to care about JSON or XML or any included errors, including the operation outcome. That's all done for you. You just return the list of results. As you can see here, because we are back in search now. Return a new, so we did the mapper, as that was the last step, and now we say create a new search result of these resources. In this case, we keep the page size, so that's effectively the top or the count. We kept that in the query, so we get it from there. And the total count that we had from here, so how many matches there are in the whole database. And then we return that, and we should be done. You need a bit of configuration, because ASP.NET Core uses dependency injection a lot. I'm not going to dive into that too much, because that's an ASP.NET Core subject. But you have to register the things you create. So the DB context, the search repository, the change repository, haven't talked about that yet, and the resource mapper. So they are created at the right time. Only 5 minutes. So this is the same as with plugins. So I would say read up on it. And in the app settings, this is the settings of Vonk. You just add your own configuration here. So you make sure your DLLs are in the plugins folder of Vonk. That can be anywhere as long as it's accessible and preferably local. Then you remove the SQL or Mongo implementations and you add your own. You can also remove from these configurations the operations that you don't want to support. So you can trim it down to the operations that you do support. One extra is a supported model. You can say, I just want to have these search parameters. And the pipeline options you just said that you just saw that in the example. This will be a bit too much for this presentation, but you can also do this with updates. And what I'm going to show you quickly is I built this, of course, and that ended up in a plugin here, Vonk VZ Repository DLL. That's the project that I've been browsing through in Visual Studio. It gives you a DLL, which is in the plugins directory of Vonk. And this also has app settings instance. That's a way of overriding the default app settings without changing them. And as you can see here, I indeed included my own configuration. here is the database. So we have 4 patient records, a couple of observations. And now we should be able to run this. As you can see, it uses the administration database to get all the metadata from. And now hopefully we can query for a patient, or all patients actually. First request always takes a bit longer for compilation and that sort of thing. So, hey, we get a bundle back. And we have a couple of entries. And indeed, here are my patients. So we see James Adams, and indeed, that is in my database. So the results should be 4. Yes, that also makes sense. There's a self-link, there's location headers, everything is done for you. We implemented identifier. Now I should take, of course, an identifier that's actually there, like this one. And we get exactly 1 result back. So that works. I could run the profile and you would see the queries flowing through the database, but I guess you just get it. Just for a reference, we can also do this for updates. So we can also post a new patient. Yep, send it. Here's the body. This is a new patient. It returns a 201 created. And if we run this again, there is a new patient in the list. So, wrapping it all up, I suggest strongly, if you want to go with this, to experiment with this. Vonk Facade Starter is not meant as a production project. It's just to understand the structure of a facade. And if you have questions, you can meet me at the Meet and Code right after, or during lunch break. Or contact us at vonk@fhir.ly. Thank you for your attention.